Today I show you how to differentiate yourself by building 9 AI agents projects across 9 industries, solving complex global scale problems. I'm giving you the architecture, tech, code, and resources to build them yourself, plus using Gemini 3 as pre-agent builder. I'm Mariam, PhD with 20 plus years in AI, teaching AI agents to 1,090 plus countries. This is the biggest flower market in the world in Amsterdam, 43 million flowers daily. But the problem that they have is that the buyer needs to know the species, quality, and prices from one photo instantly. So how can we solve this one? When I was in the Museum of Future in Dubai, I saw that they had a library of plants. You could just hand scan the plant, get information in your hand scanner with anything about that plant. So we can do that same thing for our supply chain problem for the flower market. And we call it an inventory scanner, AI agent system. So how can we build it? We need RAG, a vision model to look at our plants, put them in a vector database, use a RAG pipeline to have a real-time pricing. So for a tech stack, we could think of Gemini Pro or any kind of vision model. We could have Quadrant or Chroma for vector database, using LangChain to make that RAG orchestration and real-time auction data integration. Then link that to that market data. On a conceptual level, this is actually what we can build. On Archive, we have also a very good paper. This is the method that they use to go from a kingdom class to a species. And all of these papers can give you also extra solutions for your AI agent system. I will show you later on how we can use this also for another project. This is the problem that so many countries face. For example, Japan has the most advanced infrastructure in the world, at the same time facing all possible disasters in the world, earthquake, floods, volcano eruption, and AI can help with that. But the problem is that most of the standard AI just react, and we need something that can predict the future. So our solution is to build a geo-prediction AI agent system. In this project, the data sources are extremely valuable. It's a satellite and seismic, social media. All of those give us actually the risks. And if we look at the agent system that we can build, we use those data to go ahead and do some analysis. And this data is basically time series. I will show you in another project how we can solve actually time series problems with LLMs, but we could also use the LSTMs. And we look at the seismic data, then we can use some satellite monitoring agents. So it's multi-agent system. So the second agent is just looking at the satellite, we'll monitor, we'll look at it and we'll say, are they ground displacements? The next one is a weather correlation agent. So we know how much rainfall and flood are correlated. So that's another signal that we can get. And then we look at historical pattern using a RAG. So if anytime we need actually a system with some databases of text, we can use RAG. And then finally, prediction coordinator agent can do something of a machine learning the simplest way and combine all of these signals. Basically, we combine a number of signals together to get a very good prediction. For a tech stack, think we need always a reasoning LLMs. We need some platform to put like Grok. We need raster vision for satellite imaging. ChromaDB, of course, for our geospatial embedding, and LangGraph or any kind of the frameworks. It could be PydanticAI. I kind of teach all of that. All of them are for this problem completely suitable. And then you build your multi-agent system. Remember, the breakthrough is combining big signals, all of that ground shift, rainfall, historical pattern, and then you can give very good prediction. And our prediction basically can go ahead and make an alert system. And as I said before, it's not only for Japan, but so many countries have these different disasters, and we can do this kind of project for all of those countries. Literally every country in the world has an infrastructure. My PhD on using AI to predict asphalt quality won the European gold medal for future vision. Why? Because it impacts every road in the country, saving millions in money and lives. Asphalt is insanely expensive, and on highways, hidden damage causes fatal accident. The problem is we need to see the damage on time, and our solution is to build actually an infrastructure agent. So what we need to do is to understand actually these damages, detect the severity of them, and also exactly how many months until the failure, so the maintenance. Let's take a look at our solution. What we can do is some inspection agent. If you're asking why, because you can just not go ahead and do any kind of measurement when people are driving. You always have to arrange the inspection. Then we want to classify our severity. After classifying it, we can go ahead and do some maintenance planning. So we've got our inspection agent, our severity agent, maintenance agent, and when we know that in our system, our historical data, what is exactly the amount of the number of months which is correlated with the damage. So then we can get that one from a RAG. And then we've got a cost optimization agent. At the end, you can always go ahead and do an optimization problem. So we've got severity check planning, optimization, and then we've got our optimized repair schedule. So the key benefits are we have very minimized downtime for our infrastructure. We can use this also for bridges, but of course the same goes for railway. In the department I was working, both road and railway was doing exact thing, because basically all of them are assets, and most of the time you need to know the material and the mechanic behind it, and then you can predict anything. Meaning that you always need to work with the specialists, with civil engineers, and understand the physics behind all of these materials. It can take months to gain that knowledge. I will show you later on how to speed up that process with Gemini 3. Healthcare is a billion-dollar industry. It's one of those things that all of us need. So we're also going to build medical AI agents. But just before that, if you get confused when I explain about the framework of AI agents, they are basically like different libraries of Python with different capabilities. Some of them are really detailed, like LangChain, and some are very on high level, like CrewAI. And PydanticAI and OpenAI SDK are somewhere in between. And of course, we have also MCP. But all you need to build AI agents is a decent amount of knowledge in Python programming. I have all of them in my AI agent mastery training, and you can just check the link in the description. And if you want to start today, I made one module of my training for free. It will bring you from zero to hero. It's a 30-minute deep dive. There is also a valuable free guide included, and link is in the description for that as well. Okay, now the healthcare project. This is the MRI scan right after he was rushed to the hospital. He had a severe infection and only hours to live. In that moment, doctors have the technology, but their priority is saving his life. They cannot trust black box algorithms. They need to know why a decision is made to act fast. Black box AI is dangerous here. That's why we choose Explainable medical AI agent system. Giving you a sneak peek to the code, you need to start building that, for example, with a LangGraph. You give classes, and then starting with parsing the documents. The way we build it is by parsing those documents, so MRI, patient history, any kind of data about the patient, then anonymization because of the privacy of the patients, some preparation of the data. You can imagine that there are lots of terminologies and we need to convert units. Then we need a vector database of medical literatures. PubMed is one of the famous ones. Then diagnostic and predictions. And here we need multimodal reasoning, imaging, lab symptoms. And also we can use specialized LLMs here. And after that, we can use explainability agents that generate actually human readable reasoning. The key benefits are here that it's basically very transparent and explainable, and is secure for medical staff to use. For the tech stack, as you can see, a lot of familiar one. Exactly as before, you can use LangGraph or PydanticAI, Chroma for database. Gemini Pro is a very good multimodal medical system. And of course, for explainability, we can go for SHAP values, which is a very simple library to use. In a later project, we can use SHAP again. By the way, there are so many papers you can get inspiration from and also learn the techniques, Explainable AI, the Stanford Medical Imaging, and also GraphRAG. Talking about GraphRAG, we are going to build GraphRAG in the next project. Financial crime is another global problem. As I said before, I have 20 plus years experience in AI, and I've spent 5 years of that fighting against financial crime, tax evasion, human trafficking, and terrorism. Criminal moves money and the goods through different countries and hidden in billions of transactions. They hide behind a complex web. That's why we need to use graph to capture the complexity, but also combine the data of different banks and financial institutions to achieve that. We call it a financial crime detection GraphAI agent system. So how does the architecture look like? Of course, as I say, a graph database. Neo4j is a paid one. You have also a lot of free libraries. After that, it's all about anomaly detection with isolation forest or autoencoders. Of course, we need LM for generating a narrative, and we can build our agent to investigate that collaboration. Here, the complexity of agent is not so high, so we can use CrewAI, one of those 5 that I also have in my course. And finally, you can put everything in a vector database for having the entity matching. So we have network analysis, anomaly detection, LM narrative, agent collaboration, and entity matching. And finally, we will have this coordinated investigation. It will look like that you will see all of the transactions, find a suspicious pattern in a graph, and then we'll say what's exactly causing it. And because we are using a collaboration between the investigator and AI agent, we can build then prosecutable cases. Do you remember I said we can use it for another project? This one is also when we make that key differentiation by adding that explainability on top of everything. Microsoft has a good GitHub on GraphRAG. You can check it out and see more detail on it. Everything brings us from A to B needs logistics, and it's a global challenge. This is Rotterdam Harbor, the biggest in Europe, 30,000 ships and 50 million containers annually. But the logistics are a nightmare. This is the cost of one delayed ship, 200 plus missed connection, cargo doesn't make connecting flights, trains, perishable goods spoil, contracts are breached, and millions in penalties and losses. So we definitely need to build a logistic AI agents, another amazing AI agent system to be. I've already shown you so many AI agents up to now. Let's see what's different about this one. So we need state management. So that's memory. We need to keep track of everything. And same as everywhere, a specialized agent, container optimize. But what we also need is a feedback loop. We do not need 50 agents here, but agents needs to work the whole time online and refine their plans and then execute them when it's ready. So the first one, the agent optimizer, will just decide which ship to serve first. Think like a port manager, creates a plan, ship A, C, and B. The second one is a validator, will look if the plan physically is possible. Ship A fits berth A, crane available. Ship C, too big, so not valid. So send feedback. Ship C won't fit. Try again. And agent 3 is basically the monitor. Watch for changes, trigger replanning. Every time something happened, the monitor agent would change the planning. As you can see, a very complex system, you can still compile it down to 3 AI agents if you think about the logic behind it. So the type of papers you can use is, for example, warehouse logistic, and they will give you different solutions on this area. And this GitHub on responsive AI clustering supply chain can also be very useful for this one. So we'll show you actually the complexity and how to handle that for such a situation. When I was applying AI in energy sector, we found an impactful fraud type. Illegal cannabis farms, they steal massive amounts of electricity and they cause huge fires, destroying large apartment buildings. So it's a 4 billion annual cost in Europe. It's huge. And the fires from overloaded circuits kill people, burn buildings. You have a big safety risk. And They use about 10 times normal household electricity, but they hide consumption patterns. So the challenge is detecting that subtle signal manipulation in terabytes of meter data. Why traditional methods fail is that if you have a rule-based system, you have rules and detectors, and the criminals adopt faster than you just update the rules. And simple anomaly detections will not work because we have a lot of false positives. So we can use LLMs, which are the next token predictors. So now we can actually predict the next signal, and we call this energy and signal AI agent system. The architecture is basically the same as the problem that we explained. We have a signal collection agent, ingest the data, we get like all of the meter data. Then we will have a pattern analysis agent. We will use a transformer model trained on energy consumption. And then the anomaly detection agent compares the predicted and the actual and will flag unexpected spikes and unusual consistencies like a phase imbalance. Then investigation agent, we will have a RAG system, for example, generating investigation priorities, 72% match with a known gross household signature. Finally, we will have a fire risk assessment agent that will look at the overheating risk and also wiring capacity. This is where we create that big alert for immediate dangers. The tech stack, as I said, is a time series transformer. We have LangGraph, we have VectorDB, and we can use PydanticAI from all of the different frameworks. PydanticAI can handle structured data the best. To remember, we have had that hand scan. Also, you can use that for this project because you can scan just apartment plans and then immediately identify which apartment has this cannabis. And that helps a lot with authorities like police and fire department to make people safe in those apartment buildings. Let's enter the world of education. There are 2 billion children in the world and it's only growing. Children all need education, but in conflict zones, education looks different. Talent is everywhere, but accessibility and opportunity not. So how do we inspire a child in a limited situation to progress limitless? Let's build an inspirational education AI agent system. When children can picture who they might become, they can shape how they see their own potential. So how does the tech look like? You will have a vision agent, a career knowledge RAG agent, and a voice generation agent. The first one will get like face recognition, a style transfer, get the child's photo, and then will generate actually various settings in a hospital, lab, or space station. And then the career knowledge is where we put everything like career paths, requirements, localized to child's country and language. Then we have 11 labs for multilingual voice generation. And it will give us, okay, I know school is hard right now, but imagine if you become this. And we combine that with generated image into a video. And that inspires career guidance for a kid. The tech can be done, for example, with CrewAI, Gemini Provision. We need some kind of fine-tuning with LoRa because we want actually professional portrait generation. Then we can use, for example, LangChain for building the RAG. So we can combine 2 of the frameworks, 11 labs for voice generation. We can use MoviePy for video assembly and combining the media. And we can generate a multi-model tool which should look like this. You get the child's photo and then output a 30-second video where tell the child what they can become. And the key mission is the technology should expand possibilities, not limit them. So the cost of this could be really, really low. Cybersecurity is another major industry that helps a lot of us. Just before getting into cybersecurity problem, let's do the Gemini 3 pre-agent that I promised. Although it's a very short demo, it can save you weeks when doing these projects. So here I'm in Google AI Studio, asu.google.com. I have used Gemini 3 Pro View. I have uploaded the security logs data for our cybersecurity project that I will show you in a minute. The data looks like this. And I've asked, analyze the attached data security logs, return the result to me as a nicely formatted HTML. Why? Because for each of the projects that you have to do business understanding and data understanding. I'm going to show you how to do data understanding much faster. So you just feed it, then it starts with analyzing, defining, crafting, refining, designing, and building. You will see him build. Then I will say, where can I find the generated HTML? And it will give me the generated HTML. If I click on that, I get this data, which is amazing. Later on, if you see me building that project, you will see that these are the extraction that I've done all with AI agents. So high priority alerts will come with all of the event types. It came with all of the events, the unique user, brute force attack. We have escalation, traffic data, and analysis. And you can ask more questions and understand your data even better. So I went look at the time series of the event, show me. It will show me actually the event time for the user, for a specific user, and the time series of that. It can also give me some executable codes, all in Python. Then I tested the business understanding. So where can I find the complete SOP of cybersecurity attacks? It gives me a list of golden standards. Then I ask, can you download it, extract information, and create a visual HTML that I understand every concept. It's amazingly done. He has done exactly what I asked. Went to NISTS and then created preparation, risk assessment, and everything. Then detection and analysis, what you have to do, the documentation, everything. Then containment, eradication, and recovery. You can see every concept has been explained, and then post-incident activity. In this way, I can become a cybersecurity expert way faster. When I was doing my PhD, I had to become a civil engineer, but I had to also study that for months to get each concept. But now you can do all of that in hours. So I want you to pay attention and use that. Gemini 3 Pro looks to do it really well. The code execution, please put it on, and grounding with Google search so you get valid information. I noticed that this is the first time that you can really trust a lot of this information. One tip, do not make a very long conversation with Gemini Pro. It just confuses. It doesn't have a very good memory in my experience. Perfect doesn't exist. It's really good in analysis, but start your chat very often and don't put all of the analysis in one chat. Its context window is really not that great. I have a context engineering video, and context engineering by itself is really important to do right. And now let's go and build AI cybersecurity defense. So you can build all these amazing AI systems. If you can't secure them, you haven't built a product, you build a target. So we need security. Cybersecurity attacks on scale can really have an effect on us, even to a degree that you cannot pay in your local bakery. So we want actually to defend ourselves against these cyber attacks. So definitely need a cyber defense one. And what you could do is a log ingestion, threat pattern, response orchestration, and reasoning agents. I have built this project in 12 steps with all of the details in LangGraph. So if you want to go from nothing to a complete dashboard for AI cyber defense, watch this video. I see you there.